So that's where cloud native security gives you the tools to implement some of these controls, but insider threats will still happen, and you need to have a robust incident management, detection, and response strategy to deal with those.
So our guest for today's episode is Abdullah Shah. He is cloud and security architect with a track record of building highly scalable and mission critical products for top Silicon Valley startups and Fortune 500 companies. Currently, Abdullah is part of Salesforce Cloud Security Engineer team. He is leading teams who are building cloud foundational services in the area of network security, data engineering, and TVM across multiple substrates and cloud environments. So Abdullah, welcome to the show.
Thanks for having me.
So today we'll talk about best practices for developing and deploying cloud secure native applications. So Abdullah, what is the difference between a traditional application security and a cloud native security?
Right. Thanks. First of all, happy to be here. Right. Just taking a step back in terms of traditional IT requirements for developing applications and security. Right. Before the cloud, the responsibility actually falls on the developing teams. So they have different teams that manage infrastructure. Fundamentally, you have to secure network, compute, and storage, right? So all of these components work together to provide end-to-end security. Application security does not exist in a silo, right? So in traditional IT environments, you have to spend a lot of manpower and things to actually secure all of these things at an individual level. For example, setting up hardware firewalls, setting up DDoS mitigations on-prem and everything. Right? With the shift to cloud native security, what really is important is to actually understand the context in which your application is actually operating. With the advent of cloud, you get a lot of flexibility to get a lot of cool services and infrastructure. That essentially means your attack surface is orders of magnitude higher than what it was in traditional environments as well. So that means you really have to solve the context problem when developing and deploying applications on the cloud. That means you have to model your application and understand what are the inputs and output patterns of your application. What are the interaction pieces, right? So the parameter that existed in traditional IT environments, that essentially has diluted and dissolved in cloud native environments. So you can no longer just think that a web application firewall will be able to prevent events from, say, API gateways. Yes, they will, but there are a lot of other avenues which can actually trigger security issues in your applications. For example, you don't just have API gateways anymore, right? So your applications have inputs from event streams, cloud storage, changes in databases, and all that. So all of these things introduce additional attack vectors that can happen, right? So you really need to understand the context your application is performing in. You have to secure the platform and the infrastructure that essentially enables your application, and then ultimately you have to continuously have application security in a cloud native environment.
Okay, so it seems like with the move to cloud, it has become even difficult.
So that's a good point. So not really difficult, but there is a notion that is called the shared responsibility model, right? That comes with the advent of this cloud, right? So that essentially means that just talking about the shared responsibility model. So traditionally, all of the infrastructure that existed before, which was managed by IT teams on-prem, now a lot of that has been sort of outsourced to cloud providers, right? So cloud providers have the responsibility of securing their infrastructure and the software layers that they operate, right? These are what we call the inherited security controls, right? So that is what we inherit from the cloud providers themselves, that they have the responsibility to secure their own infrastructure. Then comes the shared model, where customers essentially have to actually secure the things that fall into their domain. That means configuration management, that means change management, things that are in your control yourself, right? So that means securing the databases, having encryption, in transit, in rest, things of that nature, right? So cloud providers will give you tools to secure all of these things, but you ultimately, customer, has the responsibility in this shared model to apply the right configurations and security guardrails at that layer, right? And the third thing in this shared responsibility model is highly specific to customer and the regulatory environments you are actually operating in. For example, right? I mean, if your application needs to abide by GDPR, then you have to make sure that the data and the privacy of that data and the compliance is according to the regulations where you are actually operating in. So I wouldn't say it has become more difficult with the advent of cloud, but it does mean you have to look at it from a different lens. You will have all the tools to secure your applications, but you really need to invest in security to make sure that you have a robust and secure application.
Okay, so how does all of this translate into developing products or maybe having a software development cycle?
Right.
How do you add features which are secure and which are sort of like abiding by all of these rules?
Right. So that's a very interesting thing. The software lifecycle, right? So we want to call it the secure software development lifecycle, right? And it has a bunch of things that need to be taken care of, right? So it's no longer that we just have applications or third-party APIs or third-party open source libraries that we can use in our applications. That is all good and fine. But the idea to actually have a secure automated testing pipeline has to be built in to all stages of your application development. For cloud native security, you have to protect all of the assets that you actually have deployed on cloud. That means, first of all, understanding the context of your application, understanding the substrate your application operates in, like the containers or VMs, so you have to take care of OS level things, app level things, containers, right? And it all boils down to a bunch of different good principles or best practices that have to be followed in following the secure lifecycle development, right? First of all, there is a thing called applications static testing. That essentially means that all of the source code and the third-party libraries that your application is actually using has to be statically analyzed to see if there are any vulnerabilities. That has to be built in to your CI pipeline, right? Then there is dynamic application testing, right? That essentially means that once your application is deployed, another name for it is penetration testing as well, where you actually see like scan the ports or scan the IPs of your space and see what are some of the things that are open and can leave you vulnerable, right? The third part of that is integration application static testing. That is similar to dynamic testing in terms of it operates dynamically, but its goal is very different. Its goal is to find out runtime vulnerability. So you have to have runtime scanning infrastructure in place that continuously scans and monitors your environment, right? And more recently, there's another thing that has come into picture that's called runtime. It's called RASP, runtime application self-protection, where your applications are built in a way or are supported by services that essentially detect these issues that happen at runtime and then do self-mitigating actions, generate real-time alerts, right? Something suspicious has happened. For example, there's a DDoS going on. How to detect that and automatically remediate that. That is what falls under RASP. So all of these things together, static application testing, dynamic application testing, static also includes configuration management, integration application testing, and runtime application self-protection. All of this contributes together to create a secure lifecycle deployment for an application.
As a startup founder, I'm a bit sort of like afraid of actually going to cloud native. Is this the case? And what are some of the like best practices for actually developing such applications?
Right. So I wouldn't say that startup founders should be afraid of following all of these things, right? These are just the lay of the land with modern application development. All of these things are required because you have so many tools at your disposal right now to have such fast application development that essentially requires you to pay attention to securing that fast prototyping and developing. That's where all of this comes in. This should be looked at as an opportunity to develop fast applications with additional robustness built in, right? That's where this, once you create this software application lifecycle development process, and it's set up with the right thing, the benefits are huge. You can sleep sound at night, knowing that you have the right guardrails and infrastructure in place to develop fast applications, but at the same time having those applications really secure, where security is built into each stage of the application development.
As a startup founder, I'm developing and building an app on AWS. So give me some of the best practices for doing so to build a secure product.
Right. So I think without tying it to a specific cloud, right, like AWS, there are a few fundamental things that you need to take care of to make sure that your application is secure, right? So at a higher level, there are a few things, right? So I'll go into each of these in detail, but identity and access management, encryption, threat monitoring and response, data privacy and compliance, automated security testing, right? So these are some of the major things that you need to take care of, irrespective of what cloud you are going to deploy on. Right? In terms of identity and access management, there is a principle of zero trust, right? That essentially you should not trust anyone. That means any and all entities that are communicating with your product or your application, they have to be authenticated and authorized, right? The thing called authn or authz. That's what that means. This essentially means that you have to define the model your application, right? Who are the actors who are going to access it? What are the level of privileges that they have? And then cloud providers will give you tools to implement those identity and access management. The second part of that is encryption, right? So data encryption is really important, right? So there are different types of data encryptions, right? In transit, in rest, and there's also something called in use, right? But encryption is really important so that, I mean, in transit, if someone is eavesdropping on you, unfortunately, it has to be encrypted so that they don't see anything. At rest, they have to be encrypted, that if somehow someone has access to your data, they can figure out stuff because it's encrypted, right? And in use essentially is a recent term, but that still means that while you are operating on data, it should be encrypted with the right level of IAM in place, that only the right people or services or actors can infer the information that is encrypted in there, right? The third part of this is the threat monitoring and incident response. That means that the applications that you have built and deployed on cloud, you need to have an infrastructure in place that continuously scans and monitors for threats. And once a threat is detected, you actually have a way of responding to that threat, right? If that means that you have to cut off a server because it's compromised, you need to have those mechanisms built in. It can't be an afterthought, because otherwise the blast radius can be huge, right? If you don't have a mechanism of responding to a threat, right? So detecting threats and responding are also really, really critical. The fourth part is data privacy and compliance, right? That also falls into, so different regulations have different localities, have different regulations and laws concerning the privacy of the data and the compliance that applies to locals, right? Again, I'll make an example of GDPR, right? Or SOC. So all of these things essentially fall into what are some of the compliance mechanisms you have around your application and organization as well in general that contributes to developing these applications. And the last thing is automated security testing. I cannot stress enough how important this last part is. This goes back to the earlier secure software development lifecycle, right? So automated security testing means that in each stage of your application developing, in the CI/CD pipelines, ideally, you have all of these controls built in, right? Static application testing, then dynamic application testing, and runtime application testing. So all of these things have to be built in. So these are 5 major things that you have to take care of. I think one additional thing I would say is secure your APIs, because those are the point of entry into your applications, right? So it's really important to model the communication patterns that your application is going to exhibit and have your APIs really secure. That's about it.
Okay, thank you. So when it comes to infrastructure as code, so does this help with the process, or is it adding more vulnerabilities to the system?
Right. I think this also ties back to the that with increased flexibility and increased power comes greater responsibility, right? And cloud and infrastructure as code, right? So these will give you the flexibility and the ability to develop applications at a rapid pace, right? But at the same time, if not properly looked at or not properly vetted, these can leave your infrastructure and applications prone to open vulnerabilities, right? And the infrastructure as code especially, so for example, if you are deploying Kubernetes or the infrastructure like with security groups or things of that nature, so if you do a misconfiguration, the consequences could be huge. That is why it's really important to have this automated security testing at each level of your CI/CD pipeline, including infrastructure as code. There are different frameworks out there that help you do that. But you ultimately have to have that mindset that
So let's just talk about how do I de-risk it?
Right. So the de-risking part is, again, it ties back to the automated security testing, right? So if you want to de-risk your environment, you have to have these static application testings built into your pipelines, including infrastructure as code. That means scanning your infrastructure as code to look for vulnerabilities, right? Is this an open port that shouldn't be open? Is this a wrong mount that is happening? Are we opening up communication for something that is not desired, right? So all of these checks have to be built in so that you fundamentally de-risk your environment.
So Abdullah, are monoliths more secure than microservice architecture?
I wouldn't say they're more secure than microservices architecture. There is a valid point saying that you have a monolith, so you essentially can just package it into one thing and just try to secure the parameter out of it, right? But monoliths increasingly are just a pain. You cannot innovate fast enough. You cannot add new features efficiently. That is why microservices architecture came in, where you decouple the responsibility and are iteratively able to improve and iterate and improve your product really fast, right? So there is always a balance in pro and con, right? So monoliths will have higher latency in terms of adding new features and everything, but maybe they have a very controlled environment where you can just control the parameter. But the same thing does not apply to modern architecture, because the modern architecture requires you to have very fast prototyping and developing. And the con that comes with it, I wouldn't call it a con, but the things that come with it is that you have to invest and see how to secure that distributed infrastructure that was previously just in one place now.
Okay. So how do I proactively prevent any security threats?
I think the one of the things that ties back to the best practices things, right? So active threats, you continuously have to have environments scanned, both from a static code point of view. We keep going back to this, right? So static application source code testing is really important to find out open vulnerabilities that exist in the open source libraries or in your own code, right? Or things like credentials being pushed up into Git or things of that nature, right? So you continuously have to scan for static problems so that they don't manifest themselves out there. So you catch them before they're even deployed in the wild, right? So that's one part of it. Then the second part of it is once it's deployed, you still need to have a model around your application that these are the communication patterns. And then you stress test those application patterns and see if there are any open vulnerabilities out there, right? And the third is the integration dynamic testing, right? And that essentially means that you have runtime scanners for the applications that are deployed, scanning the OS, scanning the apps, and scanning the containers or VMs, whatever your substrate is, to continuously find out any runtime vulnerabilities. And if there are, there has to be a pipelines that processes those vulnerabilities, generates the right alerts, and has a mechanism of mitigating those. That will fall into having a strategy of a continuous patch management solution. You have to continuously apply patches to these applications wherever they are deployed. Right. So these are some of the things that you can build around your infrastructure to or include them in the pipeline so that everything is secure end to end.
Okay, and there are concepts like security at rest and security in transit. Can you please explain those?
Right. So I think it mostly just ties to encryption that is either in transit and at rest. Right. So the SSL is the most commonly used thing to have everything encrypted while in transit, right? So if services are communicating to each other, or if users are communicating to services, there has to be SSL enabled communication, so that no one can see the communication. Even if they see it, they can't make anything out of it because it's encrypted, right? And the second part of it is the encryption at rest, right? So every application, it does something, not every application, but most applications, right, when they do something, they compute stuff and then ultimately store it somewhere, right? That storage has to be encrypted as well, because you cannot predict, or you can never say that these things will never be accessed by anyone else when they're at rest, right? Those things, breaches can happen. So it's important to have all of your data stored, even at rest, encrypted.
Okay. So all of the data, I mean, how do you define, is it going to be the entire application data, whichever is at rest or in transit, all of it needs to be encrypted? And also in terms of IaC, how do you define the boundaries? Okay, how do you define those policies?
So I think that's a good question. So the idea that all of your data has to be encrypted, right? Ideally, yes. But of course, there are costs associated to it, right? When you encrypt data at rest, it ultimately becomes a problem of key management, right? So that means that you have to have additional investment, either through some cryptographic material provider, or manage your keys yourself. But you have to have an additional investment to make sure that everything is encrypted. Then you have the right mechanisms and security applied to have the keys secured. It also brings an additional overhead in terms of performance, because then you have to encrypt and decrypt everything, all of this, right? So all of this really depends on the context your application is operating in, right? So you have to balance out where you can sacrifice performance versus where there is critical data that no one should access. For example, if there's a banking application and customer data is in there, you can't not have it encrypted. You always have to have encrypted, and whatever the cost, you have to make sure that that data does not go unencrypted, either at rest or in transit. In terms of IaC, how that can help in all of this is, right, it can help you to enforce policies. For example, right, like cloud providers have these storage things, like Google Cloud Storage or AWS S3. There are mechanisms you can enforce policies that anything that is stored at rest in these storage solutions will have to be encrypted, right? So that's where IaC can help you define and enforce those policies, but it still has to come from a security mindset and having the right guardrails and the mindset to essentially secure everything, right? That's where IaC can become a tool to help you enforce those policies.
Okay, that's great. So there are concepts like DevOps and Devsecops. What are the differences?
I think this is, I don't want to call it a subjective thing, but in my personal opinion, right, Devsecops is just a subset of DevOps. People do tend to separate these things out in saying that DevOps is purely just CI/CD and infrastructure as code that just allows you to rapidly develop applications and deploy them, right? Devsecops, on the other hand, is where people say that your automated security testing is built into the pipelines themselves, right? So it's development and security operations. So they want, it's sort of decoupling the application, continuous integration and deployment with additional guardrails that essentially just perform security specific functions. Like static source code analysis is an example of Devsecops, right? Or configuration management in terms of analyzing what is your configuration of your infrastructure as code. That also comes under Devsecops. But in my mind, Devsecops is just a subset of DevOps. A right DevOps pipeline has to have security built in. It can't be an afterthought. So that's at a higher level, right? So Devsecops directly targets the security specific things in a DevOps pipeline, and DevOps pipeline is essentially just the application's continuous integration and deployment.
Okay, so how do we handle some of the insider threats in terms of security?
Right, so I think insider threats is a very interesting topic because there are models and things that you can actually use to predict some of those things, but largely they are very hard to find, because that essentially means that either you have some unauthorized user or access who has their privileges elevated, or there is some sort of malicious insider user that essentially has access to data and they somehow export it out, right? So insider threat is generally a very vast domain that happens within security. In terms of specifically cloud native security, what cloud native security helps you is, again, right, it provides you the tools to mitigate some of those things. For example, you can set up the right access, identity and access management, follow the principle of least privilege, right, where only people who have access to data only have access to data what they are supposed to access, right? And then you can also establish, like, for example, parameters around services, right? For example, this data from this storage bucket can only go to XYZ destination. So even if someone has infiltrated in there, they cannot exfiltrate data out of that domain because there are guardrails around it. So that's where cloud native security gives you the tools to implement some of these controls. But insider threats will still happen, and you need to have a robust incident management, detection, and response strategy to deal with those.
Okay, so Abdullah, there are applications that are public facing, and users are sort of accessing it, and they also become the conduit to actually getting into any of the applications. How do we protect that from happening?
Right. So I think that's essentially what comes under the social engineering sort of attacks, right? Where people are tricked into sending their credentials somewhere, which can then be used to essentially access unauthorized things, right? Like if you took an example of Twitter, right? So someone has essentially tricked you into giving them your credentials, and then they have essentially, it's a matter of privileged access. Their access levels have increased and they can do things on that behalf, right? So it's really important in that sense that the applications that are essentially built this way have the right guardrails, where if something like this happens, first of all, detecting it is hard, but there are still algorithms and patterns that you can use to detect some of this activity. But in most cases, these things are sort of notified to companies that, okay, this has happened, right? But once that has happened, you need to have a robust incident management response strategy where you can just shut down that particular user or that particular malicious actor immediately so they can damage a lot more. So at that point, it becomes damage control and controlling the blast radius. So that's where I think that comes in.
So as a company, I'm providing payment solutions to our customers. So how do I ensure the safety of the data that resides with me?
Okay, so I think this also falls into the category of knowing the context where your application operates in, right? What context your application is operating. Specifically for payment solutions, right? Payment industry solutions. So there is a specific standard called PCIDSS, right? Payment Card Industry Data Security Standard. It has a bunch of principles, checklist essentially that has to be taken care of for any application that provides a payment solution, right? So few of those include having active firewalls, having the right IAM, having encryption in place, protecting the cardholder data, so that application doesn't actually store it somewhere where someone else is seeing it in an unencrypted form. So all of these things, there is a standard that exists, right? So any application that is being built to do payments has to abide by those solutions. Mm-hmm. What is important to note here is that with the increasing amount of cloud providers, all of those cloud providers, they themselves take care of making sure that their services are PCIDSS compliant, right? So for example, AWS has a bunch of services who are PCIDSS compliant, including Lambda, AWS API Gateway, or S3, all of these. So what that essentially means is that you can use these services knowing that at an infrastructural level, they will be PCI compliant. But still, as an application developer or a company owner, you still have to make sure that whatever you do, you have the right vetting in place to make sure that you are abiding by all of those standards. Is there an application or is there a service that you are using that does not have the right PCI implemented, right? So you have to, that's where the customer responsibility model comes in as well. You have to know the context your application is operating in, Cloud providers will give you the tools and ability to make sure that you're compliant, but ultimately it's your responsibility to make sure that everything is end-to-end compliant.
Okay, so I'm building an app for a fintech startup. So are there any sort of guidelines available that needs to be followed? Because you mentioned these guidelines that are there for the financial transactions.
Right. So that's where that PCIDSS is. It lists list of guidelines that have to be satisfied and vetted by outside security testers or auditors to make sure that your application is following all of these standards and is actually compliant to be able to operate in fintech industry. Right? That is what PCIDSS is.
Okay. Right. So Abdullah, what are some of the key actions that we should take to make sure the right people are accessing the system?
This boils down to really modeling your application, knowing the context that it operates in, knowing all of the inputs that are going to essentially exercise your application, the outputs that it generates. If your application has a bunch of services, the communication patterns between those services, right? What does this service need to talk to? What are some of the communication pathways or patterns that should be opened up? So we generally, this notion of zero trust also comes into play, right? Where you have to have the authn and authz at the heart of your application development, where everything has to go through an authentication and authorization, right? So fundamentally, once you model your application and you do these are the inputs, these are the outputs, then you do threat modeling analysis as well, right? All of that plays a role into defining the right identity and access management strategy for your application. Because you can only, cloud providers will give you the tools to implement all of these things, but it is ultimately your responsibility to make sure that these are the access patterns that exist in my application, and then how do I use the tools that cloud providers provide us to implement strict controls on those access patterns.
Yeah, let's just talk more about this. So obviously cloud providers are supposed to be secure, but seems like cloud security is another sort of like a bigger concept. So if you can.
Right. So this falls into, again, the shared responsibility model like we earlier talked about as well. Right? So cloud providers have their own layer of infrastructure and software and hardware that they are going to make sure that it is secure. Right. If there is a breach in there, it is the responsibility of cloud provider to take care of it. But then there is the second layer where the customer comes in. That is where the robust IAM strategy, patch management, config management, and all of these things come into picture. The customer has to make sure that the applications that I'm deploying are in the right compliance and have the right security, which means having the right rules in place to essentially defer or deter any exploit. Right? This also again ties back into the fact to have a security automated pipeline in each layer so that the applications that you are developing and the things that you are responsible for are covered automatically in the life cycle of that software development. Right? That would mean, again, static application testing, dynamic application testing, having the right configuration management checks on the things that you deploy in the wild, having infrastructure as code vetted with solutions like OPA policy and things of that nature, right? So that's all that really ties into this in this shared responsibility model, and customers have to know the context of their application, model it, and then implement the right security strategy around it.
So in the context where application spans across different providers and maybe on case where the public cloud and on-prem solutions are available, how do you build security in that kind of environment?
So hybrid environments are essentially a challenge in terms of how do you, because there are different tools that exist on-prem versus on clouds to prevent or to implement security, right? Ideally, there is just a single pane of glass everywhere where you can store these things, and increasingly different cloud providers and companies have these efforts where they provide you a seamless experience operating across different environments, right? So for example, Google has this Anthos where you are able to run Kubernetes engine on-prem at the same time on cloud and have a single pane of management across those things. Right? That allows you to implement some of the security controls within a single pane of management as well. AWS has AWS Outposts where they allow you to use some of AWS's stack and services on-prem as well. But ultimately, it again falls down to your strategy of knowing the context. What is the communication patterns that exist on-prem? What are the communication patterns that exist on the cloud? How do you actually secure them? Can you have one solution that spans across both? Or will you have to have different solutions that ultimately logically create a single security interface, but ultimately are decoupled in physical implementations?
And obviously there are applications which spans across geographies, and there are different rules across different continents, different countries. How does security plays in that role in that kind of context?
Right. So that's also the like I think in the shared responsibility model, the third layer is customer specific, and that also applies to the fact that where your application is operating, right? So, for example, in Europe, there is this GDPR, Global Data Protection Regulation. That means like PCI, it has a checklist of that. Okay, these are the standards or protocols that need to be followed for customer data that is stored in those locations, or this data cannot move out of this location. So if you are developing an application that spans geography, different geographies according to their data regulations or their environment regulations, you have to design your application in a way that it caters for those. You will have tools to implement those things, but it requires a robust strategy to develop an end-to-end secure application that operates in different jurisdictions and has different governing laws according to the geography.
Okay, consider a situation where a breach has happened, like it's going on, it's in the play. What kind of monitoring systems are there? How do you sort of bring the system back?
So this this depends a lot on the context, right? There are few standardized things, right, that you have to capture events that come into your system. All of those events, you have to analyze those. But it's no longer, in cloud native terms, it's no longer just, the parameter is not just one thing, right? So there are different events and things that can actually trigger your applications. So you need to know not only the malicious request's source IP, you need to know the destination, the protocol, the fields inside those requests. And there are different solutions for those, right? So a lot of companies, they build in-house things to essentially define the rules that they apply on these events, right? So for example, if there is a cloud environment and you are capturing each event coming in, you will match those events across a set of security rules. And if you find anything malicious and see that this does not fall into the common pattern, there are going to be alerts generated to a specific incident response team. That incident response team has automated pipelines in place to figure out, to see what is this event? Have we seen it before? Is this a DDoS happening? And then there are mitigation pipelines that happen that take appropriate action depending on a particular level of breach, right? So if it's, for example, DDoS, then you may be looking into the way of how do we actually provide additional rate limiting based on this particular request and things of that nature. But it all depends really on the context and the use case. But generally, continuous threat monitoring and incident response are one of the very critical functions of having security in a modern day.
Okay. So is there a case like you have a security system or policy in place which is much more reactive than proactive? Are there differences in those approaches?
So reactive, again, this I think falls into the incident response thing, right? So once you detect an incident, what do you want to do? That has to be a solid strategy, right? Depends on the application context and what is the level of breach. This ties back to the right modeling of your application, that if the state machine happens, if there is a malicious thing that is happening, what are the steps that I need to take to actually cut off that thing, right? That's more in terms of the reactive thing. Proactive ties back into having the right automated security testing throughout the lifecycle development of your application.
Okay. So in terms of proactive security detection, does AI play a role?
Right. So proactive security detection, just essentially means having the right automated security testing in place throughout your application development lifecycle. Right? So what happens usually is that there are companies, for example, SNCC, right, that allows you to continuously scan your static source code, find out vulnerabilities, and then automatically suggest you the solutions as well that you can implement to get rid of that vulnerability, right? So there are a bunch of rules that all of these things are matched against, right? So whether it's static code analysis or dynamic code analysis or runtime code analysis, all of these things are essentially a set of rules that they see a state, then they compare it with a set of rules saying that is there a difference between what I expect and what is out there, right? And that at that part, of course, there are AI models that can come into picture to predict based on that. Okay, this is based on this particular vulnerability. This is the breach that can happen. So how to contextualize this full security problem is a vast domain, right? And that is where AI also plays a role in there as well.
Okay. So Abdullah, thank you for joining us. It was a pleasure having you. We can't just think of anyone better than you for this topic.
No, thank you so much for having me. I enjoyed having this conversation, and yeah.
I hope you enjoyed your time at Xgrid.
Yes, it was great having the conversations with the people around here as well, and I really enjoyed talking to the team and everything else.